In order to subtract fractions, we have to have a common denominator. When two fractions have the same denominator, we subtract one numerator from the other and keep the common denominator. The same procedure is used with rational expressions. To subtract a rational expression from another, we have to have a common denominator. We subtract the numerators and keep that common denominator. In this example here, they're asking us to subtract these two rational expressions. They have the common denominator, so we'll subtract the numerator, 8a minus 10a, which these are similar terms. 8a minus 10a is a negative 2a, and express that over the common denominator. In consideration of our answer being in simplest form, since the denominator cannot be factored any further, the largest common factor between the two terms is 1, and there is not this binomial in the numerator, we have our answer in simplified form. Here we have another difference of rational expressions having common denominators, so we will subtract the numerators. The fraction bar under this numerator is a grouping symbol, just like parentheses. Thus, when this numerator is subtracted, it's important to subtract every quantity. And to illustrate that, I'll write it as x plus 3 minus this whole other numerator, which ends up being a quantity, a subtraction of a quantity over that common denominator of x minus 4. Subtraction of a quantity we found earlier with subtraction of polynomials. We can change a subtraction by turning it into the addition of the opposite. And so we'll do that here by changing the x into a negative and the plus into a negative, and then we can add those together. Simplifying then, we have a 2x plus a minus x leaves an x. We have a 3 plus a negative 5, which leaves a negative 2 for a simplification of the numerator over that common denominator of x minus 4. In the numerator, we have the binomial x minus 2. That is not the same as the binomial in the denominator. These are not factors. They're connected with a subtraction in this particular example. And so we're done with our simplification of this problem. Let's take a look at one other one here. Same thing. We are subtracting rational expressions. We have the necessary common denominator. So again, in subtraction of a quantity, we need to not only subtract the x, but also subtract the 4. So we end up with a 3x squared minus the quantity x plus 4 over that common denominator of x squared minus 1. Subtraction of a quantity, we'll change the signs and add using our definition for subtraction. None of these are similar, so we'll leave it as a 3x squared minus x minus 4 when we combine those over the common denominator of x squared minus 1. For consideration that this is simplified, we need to next factor. Our first term, since 3 is a prime, came from 3x and x. Our minus 4 has one factor positive, one negative, that add up to be a negative 1, but also have to play off our outer and our inner when we use the FOIL multiplication that result in a 4 and a 1 factor, with our 4 being negative and the 1 being positive. The denominator is a 2-term polynomial, which we should think difference of squares, and does fit the pattern or the criteria. Square root of the first minus square root of the second square root of the first plus square root of the second. Now, looking for simplifying further, we see a common factor of x plus 1, which is equal to 1, leaving the binomial 3x minus 4 over the binomial x minus 1 for our final answer.